Hello class and welcome back to section 8.2. This is part 2 of section 8.2. Just to remember, on the last video we went ahead and looked at finding the least common multiple because we're going to need that to find the denominator when we are adding or subtracting rational expressions. On this part of the video we're actually going to be adding and subtracting rational expressions. So let's go ahead and take a look at how we're going to do that. So just like fractions, to add or subtract rational expressions, you must have a common denominator. So if we just take a look at the example I have off to the side, my common denominator between 3 and 5, well, I can multiply both of them to get them to 15. So for this case, I would have to multiply this one by 5. And remember, whatever I do in the denominator, I also do in the numerator, because 5 over 5 is 1. Okay, so that's why we can do this. And I also have to get the denominator over here to be 15, so I'd multiply by 3. Multiply by 3. So what I would really have is 10 over 15 plus 6 over 15. And if I go ahead and add them, or sorry, 9, not 6. And if I go ahead and add them together, I will get 19 over 15. And once again, I would check, can I simplify this in any way? No, I cannot. And so there we go. Now, it's a little bit different when it's variables. It looks a little more intimidating, but it's really not. Because in order to get my denominator the same, well, if I multiply this one by d, essentially like we did before, notice how we multiplied by the opposite value. I would have cd on the denominator here. In order to get cd over here, I'd multiply by c over c. So I would have ad over cd, just writing it in alphabetical order, plus bc over CD. And then remember, we would go ahead and add the numerators. So what I would have is AD plus BC all over CD. That would be my rational expressions being added together. So let's go ahead and look at another example, example 8. All right, example 8. I would go ahead and I would get my least common multiple. That's what my denominator will be. What I recommend is just breaking it apart like we did when we were finding the least common multiple. So my factors of 15 are, right over here, my factors of 15 are 3 and 5. My factors of 18, well, that's going to be 3 times 6. So 3 times 6 will break up into 3 times 3 times 2, because 3 times 2 is 6. So those are my factors of 18. Now remember, I would take, to get the LCM, it is the greatest factors to get my least common multiple. So there's 1, 2, so it's 2. Then I would take times 3, and then there's 1, 5. And then remember, it's always the greatest. So I have a y squared and a y, so it's going to be for sure a y squared, and an x. So this will be my least common multiple. So we have 2 times 3 times 5, which will give me that my least common multiple is 90xy squared. So in this case, in order to get my denominator there, well, I would have to say, well, what's 90 divided by 15? That's going to be 6. So I'd have to multiply 15 times 6 in order to get to 90. And then I would also have to multiply by x to get to xy squared. So I'm going to multiply by 6x on my left-hand rational expression. And my right hand, I would have to take 90 divided by 18 to figure out what I have to multiply that by. That's going to be 5 times 18 is 90. And I need to have xy squared. Well, right now I just have xy, so if I multiply by y, 5y, then I will get it. So if I simplify, I know that 6 times 7 is 42. X times x will give me x squared all over 6 times 15 will be 90 xy squared plus 5y times y will give me 5y squared all over 18 times 5 will give me 90 xy times y will give me xy squared. Now notice I have a common denominator. Okay, so I can go ahead and add my numerators. So I would have 42 x squared plus 5y squared all over 90xy squared. And I would make sure, can I combine any of these? No, I cannot, so this would be my final answer. Let's go ahead and look at the next example, example 9. Example 9. So I want to get the same thing, common denominator. So if I want, I can go ahead and get my least common multiple first. So I know that 9 will break down as 3 times 3. And 7, well, this one's pretty easy. It just breaks down to 7 times 1. So my least common multiple for this one, my LCM, will be 3 times 3 times 7. Well, it's really 9 times 7, which we all know is 63. Okay, and then I look at my variables. I would have a, b squared. So I need to get my denominators to be 63a squared. So in order to do so, 9 times what gives you 63? 9 times 7. And then I need ab squared, so I need to have times a, b. And then I would look at the next one. I need to get this one also to 63ab. So 7 times 9 gets me 63, and it already is ab squared, so I just need to multiply this one by 9. So when I do this, 7 times 8 is 56. I would then have a squared b all over 7 times 9 will give me 63 ab squared minus 1 times 9 is 9 over 63 ab squared. Okay, so I would combine them. I would have 56 a squared b minus 9 all over 63 ab squared. There would be my final answer. Once again, confirming or double checking that my numerator will not be able to be combined or any of that. So we are good there. Moving on to example 10. Okay, this one I can look at and I can maybe figure this out without having to write down my least common multiple, because I noticed that 1 is 8 and 1. So I know that on my right-hand expression, I will need to multiply by 8. Okay, and I have to have m squared. Well, right now over here I have m, so I'm going to do this. And then I have to have n squared. So that means over here I have to multiply by n. So let's look at my denominators. If I were to multiply them out, right now I would have 8m squared n squared plus 8 times 1 will be 8. M times m is m squared, n squared. So yes, I'm good. So I'm going to multiply my numerator. So I would have n plus 2 times 8 is 16m. So I can write this as 1 n plus 16m all over 8 m squared n squared. There is example 10 completed. If you need a break, now would be a good time. Maybe take a break. Try number 11 on your own. Write any questions you have down that you're thinking about, so that make sure that we can clarify up any problems that you might be having. If you need to, go back to writing out the LCMs like we were before. But otherwise, I'm going to move on with example 11. Okay, example 11. I will go ahead and I would look at this one. 3 and 5. Well, I know that my least common multiple between 3 and 5 is 15. So I would have to multiply this one by 5 to get to 15, and this by 3 to get to 15. Now, this has an x. I don't have an x over here, so I have to multiply by x. And then it has a y. They both have one y, so we're good. So I have to multiply by 5. Okay. And I'm just going to maybe shorten up the process a little bit. I'm just going to write it all at once. It's going to be 5 times 2. So 10 minus, well, 3x times 3x, so it's going to be 9x squared, all over my common denominator, 15xy. And there is my solution for number 11. All right, now we're going to get to where we need to factor. Okay, before we had monomials, so there's only one piece. Now we have binomials or trinomials, and we're going to need to factor. So in this case, when there's addition or subtraction involved, like this, you will need to go ahead and you're going to need to factor. So let's look at number 12. I would factor, there's nothing in this numerator, so I'm just going to factor this one out. It would be, I can factor out a 4, so it's w minus 4. Then up here I have w plus 4, and here I would factor out a 2. Now I would say, well, what is my least common denominator? Well, they both have a w minus 4, and then they have a 4 and a 2. So all I really need to do is get this one to be a 4 out in front. Well, 2 times 2 is 4, so I'm going to multiply this by 2. Okay, so I'm going to write it all at once, so just be careful because it's subtraction. So it's W plus 12 minus, so I'm going to write it out, so it's 2 times W plus 4 all over 4W minus 4. Okay, I'm going to go ahead, we should distribute this negative 2. So I will have W plus 12 minus 2W minus 18, and I'm going to distribute the 4 in the denominator, so I'd have 4W minus 16 is equal to W minus 2W is negative W, 12 minus 8 is plus 4, all over 4W minus 16. Okay, one thing I would maybe take note of is look at how this has a W minus 4 and this is a negative W plus 4. I could factor out a negative and I would have W minus 4. And I would do the same thing here. If I refactor out that 4, look what will happen. W minus 4's will cancel and we will be left with negative 1/4. So that one simplifies down pretty nicely for us. All right, let's go ahead and look at our next example. Example 13, let's start factoring it. My denominator has a difference of perfect squares. So let's go ahead and factor that. So it's going to be x plus 2 and x minus 2. Oops, so sorry. Plus x over x plus 2. There's no factoring on this one. So I would look at this and I would say, well, I need my denominators to be exactly the same. So right now they both have an x plus 2. So all I really need to do is go ahead and multiply by an x minus 1. Or sorry, x minus 2. X minus 2. Now if you notice, the denominators are the same. So I would have 1 plus x times x minus 2 all over, okay, I'm going to rewrite it as x squared minus 4, because if I were to FOIL that out, I would get back to my difference of perfect squares. And so I would have 1 plus x squared minus 2x, and the way that is happening is from distributing this x, all over x squared minus 4. And then I'm going to write in standard form, so remember highest exponent to lowest exponent. And then I would just check, if I were to refactor this, would anything cancel? Well, multiplies to 1, I would have to do x minus 1, x minus 1. And x squared minus 4 factors with 2, so there would be nothing that cancels. So there is my final answer for number 13. Okay, let's look at number 14. Once again, we have to factor. Biggest thing with subtraction is you need to be careful with that negative sign in there. So maybe we need to do GCF, or maybe we can do a guess and check type method. Let's go ahead. I'm just going to refresh once again on GCF. So I would take 3 times 5, which gives me 15. And I need to say what multiplies to 15 but adds to 8. Well, 3 times 5. So I would rewrite it as 3x squared plus 3x plus 5x plus 5. Then I will go ahead, break it apart. Factor out a 3x, so I would have x plus 1. Factor out a 5, so I'd have x plus 1. So notice they both have x plus 1, so I would factor to x plus 1. And what's left? 3x plus 5. Okay, so this factors to x plus 1 and 3x plus 5. This piece here, both divisible by 4, so I would factor out a 4, and then I would have 3x plus 5. Now if I want to make my denominators the same, I need to think, well, what do I need to have? Right now I both have an x plus 5, so over here I need a 4, so I need to multiply by 4 on the top and the bottom. And now I'm missing an x plus 1, so I need to multiply by x plus 1. Okay, so simplifying, it's 4 times x minus 1 minus, don't forget that negative, x minus 1 times x plus 1 all over 4x plus 1, 3x plus 5. So now I would distribute. Okay, so I would have 4x minus 4. And then the biggest thing here is, remember, this looks like difference of perfect squares. So this should be, I'm going to leave it in parentheses, x squared minus 1. And then if I go ahead and distribute the negative again, I'm just going to rewrite the denominator real quick. Now I need to distribute this negative to everything in the parentheses. I would have 4x minus 4 minus x squared plus 1 all over 4x plus 1, 3x plus 5. And then I would combine my like terms. I know I have a negative x squared. Then I would have plus 4x. And then I have negative 4 plus 1, so minus 3. All over my denominator of 4. And I know what this piece foils out to. It's going to be what is right here under the denominator originally, so I will leave it as 3x squared plus 8x plus 5. And this is a negative x to the second, not negative x times 2, just so we're aware. All right, and we have one last example on here. Example 15, I would highly recommend that you just pause the video and try and do example 15 on your own, just to make sure that you can. So example 15, just maybe pause it for a few minutes, try and work through this one, and then I will go through it here as well. So we're going to start out, I'm going to factor my denominator, so what multiplies to negative 20 but adds to negative 1? Well, negative 5 and positive 4 would do so. So that's this denominator. And if I look at my other denominator, it is x plus 4. So the only thing I need to add is a minus 5. So if I do that, I would have a plus 2 times a minus 5 all over a minus 5 over a plus 4. I distribute that 2. I'm going to rewrite this. It was a squared minus a minus 20. And if I combine my like terms, I will have 3a minus 10 all over a squared minus a minus 20. And that will be my solution for example 15. Okay. Example 16. It's not on your note sheet, but it is a good problem. It says find the slope of the line that passes through these 2 points. So let's just go ahead and maybe take a look at this real quick, and then we'll call it a day. So I'm going to set it up. Remember, it's y2 minus y1 over x2 minus x1. So here's x1, y1, x2, y2. There we go. So my slope, remember, is m. So I'm going to have 3 over p minus 1/2 all over 1/3 minus 2 over p. Okay, so first thing I need to do is get a common denominator. I'm going to take care of my numerator first, the big numerator. So I'm going to have to multiply by 2, and I'm going to have to multiply this one by p. Here I'm going to have to multiply by p and this by 3. So if I rewrite, I would have 2 times 3, which is 6 over 2p minus p over 2p, all over p over 3p minus 2 times 3 is 6 over 3p. So now I'm going to go ahead and rewrite them as 1. So I would have 6 minus p over 2p all over p minus 6 over 3p. Okay, one thing I want to point out is, remember when we've talked about this in the past, when you have a complex fraction, you multiply by the reciprocal, okay, so of the divisor. So really what I have is 6 minus p over 2p times 3p over p minus 6. And notice my p's will cancel. And this is really negative p plus 6. If I factor out a negative, okay, I would have negative p minus 6 all over 2 times 3 p minus 6. My p minus 6's will cancel, and we will be left with negative 3 over 2. Okay, so this is a good example. I do believe there is one like this on your homework, on your worksheet, so make sure you watch this. If you have any questions, please write them down. Otherwise, have a great day, and I will see you later.